Okay, this is our third lesson in the equation solving. For those of you that are wondering where this all fits into your separate courses, we are going to go through most of the chapter 3 of Math 053 by the time we're done, but we'll try and do starting next week, we'll have our second lesson focus on 053 topics, and our first lesson continue to focus on ones that also apply for the other courses there. Math 038 and 052, as I've mentioned, even though it's not specifically taught in your courses, they somehow have expected that you can do some basic equation solving. So I will try to make a point of mentioning when we get to equations that are so complicated that they're not ones that you would see in 038 or 052, but everything we're going to do is stuff you'll see in 053 and probably a bit beyond as well. So let's see, there we go. So remember from last time that our goal when we solve an equation is to isolate the variable, and that means to get it alone on one side of the equation. We didn't talk a lot about this last time, but think about that for a second. If you have your x alone, say on the left, if there's nothing else with it, then all that you have left is x equals and some number. That's why isolating the equation solves it, because once you have the variable alone, you can just look on the other side and see what it's equal to. And remember that the way we did this is we remove things that are with the variable one at a time using the opposite operations. So the opposite of adding is subtracting, and vice versa. The opposite of multiplying is dividing, and vice versa. In future courses, you'll run into other operations too that you do the opposites of to help you solve equations. And remember the golden rule of equation solving: whatever you do to one side, you have to also do to the other. So here's a couple like we did last time. Let's just go through them very quickly. So we ask ourselves, is the y already by itself on one side? So there's the equal sign. On the left side of the equation, no, the y is not by itself. It is with a minus 18. What is the opposite of minus 18? It is plus 18. So the opposite of subtracting 18 is adding 18. So I do that, but whatever I do to one side, I do to the other. As a result, y minus 18 plus 18, well, minus 18 plus 18 is just 0, so all you have on the left side is a y. And over here, a little bit of practice with our positives and negatives, which, by the way, when we do these positive negative additions, subtractions, that is actually not an 038 Math 038 thing. For the Math 038 students, you won't have to do that. But this means 35 to the left, 18 to the right. Oh, sorry, I'm getting ahead of myself. Yes, so we want to, and what we were starting to notice before we do that addition there, what we were starting to notice is that this second line of work that we're showing here, we can really probably start to skip it once you get good at it. In the back of your mind, you always know you're doing it, but you don't really think about it. So you start to notice that a subtracted 18 on the left becomes an added 18 on the right. Why did that happen? Because I added 18 to both sides. That one just stayed there, the plus 18, and this one canceled out with the minus 18, right? So we're going to start to move as we go through today's questions into skipping that second step. Even though we know we're doing it, what we start to do is just skip straight from y minus 18 on the left becomes a plus 18 on the right. Now we're going to do that addition, 35 to the left, 18 to the right. So we're going in opposite directions on the number line. So we're going to subtract those numbers and get 17. 35 minus 18 is 17. Did we go further left or further right? We went further to the left, so it will be a negative 17. Oh yeah. That middle slide there was just showing you how we'll often skip that middle step. Over here on this next one, is the c by itself on the left side of the equation? No, it's not, because there's a negative 3 there with it. Multiplication is the lazy operation where we don't bother to put the times sign or the dot or the brackets. We can sometimes, if it's just a number and a letter, we just write them side by side, but we know that is actually multiplication. So we're going to do the opposite. The opposite is not adding 3, because this is not a subtracted 3. This is a multiplied negative 3. So I divide, that's the opposite of multiplying, divide both sides by negative 3. And in this case, we remember that it doesn't magically become a plus because I didn't add it to both sides. I divided it by both sides. So a negative 3 on the top and a negative 3 on the bottom just cancel out, leaving C alone. 24 divided by negative 3 on the right, and we get an answer of negative 8. I think I might have a slide. Yeah, just re-emphasizing that the look at the blue, minus 8, subtracted 18 on the left becomes an added 18 on the right, but a multiplied negative 3 on the left becomes a divided negative 3 on the right. Still negative. Okay, so often there is more than one thing. All the questions we've done so far just have one thing with the variable that we have to get rid of. Often there is actually more than one thing to get rid of with the variable. So there's an example. So this equation, 7x plus 9 equals 51, there are, over there with the x, we have a 7 being multiplied very close to the x. And then we have this 9 being added a little further away. And you notice the words I'm using there, closer and further away. We think of multiplication and division because of BEDMAS as being closer to the variable, and the adding and subtracting as being farther away. And we're going to get rid of the things that are farther away first. So it almost turns into reverse order of operations. So we have to get rid of the plus 9 and the times 7. We're going to do them one at a time. So first thing we want to talk about is a constant term. A constant term is any term that doesn't have a variable. So like this plus 9 is a constant. So is this 51 over here, by the way, also a constant term. And when we are solving, we want to first remove those constant terms. And then we deal with whatever might be multiplied or divided by the variable. So the first thing we need to do is get rid of that plus 9. So here we're going to do that. What is the opposite of adding 9? It is subtracting 9. So I do that to both sides. Because on the left, plus 9 minus 9 goes away. On the right, I still have that minus 9 there, and we're going to make our little note once again that once we get good, we're going to skip that middle step. So instead of writing the minus 9 on both sides, we are going to go, an added 9 on the left ends up becoming a subtracted 9 on the right. Okay, like that, yeah. So that's what your work's going to look like once you're feeling comfortable with it. So now we'll do that subtraction. 51 minus 9 is 42. Is the x by itself yet? No, it is still not yet by itself because there is a 7 being multiplied. So what is the opposite of multiplication? It is division. I divide both sides by 7 because on the left, a 7 on the top and a 7 on the bottom cancel. And on the right, 42 divided by 7 is 6, like so. So that is your first two-step equation. And you see again what we do is we deal with the constant term first, wherever it is, if there is a constant term, then we deal with the multiplication or division that is closer to the variable. Oh, we got another one here. So negative 12 plus 5t equals 27. First question, is the t all by itself? Definitely not. It's being multiplied by 5. And there's also this negative 12. Well, negative 12 plus 5t. We're going to have to think about that, how to make that go away. And I did that on purpose. So constant term first. Let's remember what we talked about when we talked about our new way to think about the terms of when you're adding and subtracting things. Remember we talked about the fact that the sign that comes after something has nothing to do with it. So this plus sign here has nothing to do with the 12. So some people will see that plus there and they'll say, oh, I guess I subtract 12. No, this plus tells you about the 5t, right? Every term is decided by whatever is in front of it only. What is behind it has nothing to do with it. So this 12 is actually a subtracted 12. If you really want to get technical, you could imagine there's a 0 out front here to start everything off. 0 minus 12 plus 5t. But we don't bother to write it because adding 0 doesn't change anything, right? So look at your constant term. It is being subtracted on the left. So we are going to do the opposite of subtracting 12 by adding 12 to both sides, or our shortcut method, we say the subtracted 12 on the left becomes an added 12 on the right. And I think, yeah, so this is the first time that we've tried our shortcut, but don't forget, in the back of your mind, you know that's what we actually did, right? You do it the fast way, like that. The subtracted 12 on the left becomes an added 12 on the right. But somewhere in the far reaches of your brain, you never forget that what you actually just did is add 12 to both sides. Okay, so now we can carry on. 27 plus 12 on the right is 39. Is the t by itself yet? Keep asking that question over and over till it is. No, the t is not by itself. It's multiplied by 5. What is the opposite of multiplying by 5? It is dividing by 5. So I divide both sides by 5. Don't freak out when this doesn't work out nicely. Don't reach for your calculator and turn it into a decimal unless the question specifically tells you to. We stick in fractions unless they tell us to go to decimals. 39 over 5 is a perfectly good answer. There is nothing wrong with that answer, although read the instructions, because if they say to go to a mixed number, 5 goes into 39 7 times with 4 left over. So 7 4/5. There are students who are very hung up on grabbing their calculator whenever the numbers don't divide nicely and giving a decimal. But we do not want decimal answers. We want fraction answers almost always, unless they specifically tell us that we want decimal answers. Okay, so there we go. We have, this is the first time where we're showing our work without the middle step. Added 9 on the left becomes a subtracted 9 on the right. Subtracted 12 on the left becomes an added 12 on the right. And then get rid of the multiplication by dividing both sides. All right, and let's never forget that with equations, we have this wonderful ability to actually check on the test if we're right or not. You can't do that with most questions, right? You come up with an answer and you write it down and you hope that you got it right. But with equations, we can always check and see. So for example, on the first equation was 7x plus 9 equals 51. We got an answer of x equals 6. Let's double check and see that it's actually right. So we're going to take the left side I've put there in red and the right side I put in blue. We are going to work them both out separately to see if x equals 6 does make them equal. So on the left we have, 7x plus 9. So if you look at the right side there, it's 51. Well, in this case, there's nothing to work out, although we've seen sometimes there can be variables on the right as well. Over on the left side, we're going to replace the x with a bracket, and into that bracket goes a 6, the number we're checking. Now just work it out. 7 times 6 is 42. 42 plus 9 is 51. Perfect. Our answer does work. It does make the left side equal the right side. Okay, so yeah, we got a few here for you to try. So these are 3 classic kind of 2-step equations. I've given you one little reminder there on the first one. We just see an 8 out front. Is that 8 being added or subtracted? Remember that if there's a plus, we don't need to write it, we don't bother to. So if there's a plus at the very front, we just leave it out, but it is there. That is actually a plus 8 at the front, which you will get rid of by subtracting 8. So I'm going to give you maybe 1 minute per question. So let's go 3 minutes. Give those a try in your paper, and then we'll look through them together. So, like I said, these are all sort of classic 2-step equations. What makes them 2-step equations? They all have a constant term, and then something either multiplied or divided by the variable. So remember, in all of them, we want to make that constant term go away first. The way you think about that kind of loosely is that it's further away from the variable, right? Look at how close the things that are multiplied or divided are to the variable. You have to move away the things that are further away first. So that 8, we remind ourselves, is actually an added 8, right? And also, maybe it's too bad I could have made that a negative sign right there, because if that was a minus sign right there after the 8, that wouldn't change anything. right? The 8 would still be added, even if there was a minus sign after it. Only the thing in front of the 8 tells us whether it's added or subtracted. So we're going to do the opposite of adding 8, which is subtracting 8 from both sides, or we're going to take our shortcut and say that an added 8 on the left becomes a subtracted 8 on the right. And I think I get fancy here. Yeah, look at that. A little faded out version of that intermediate step that we're skipping, where we know that in reality we are subtracting 8 from both sides, but what that looks like is an added 8 on the left turns into a subtracted 8 on the right. So what is 21 minus 8? It's 13. Now, is the d by itself yet? Nope, it's being multiplied by a 2. So we do the opposite of multiplying by 2, which is dividing by 2 to both sides. And we don't care that we got a fraction answer. It's actually less work, right? If you can just say the answer is 13 over 2, it's actually less work than turning that into a decimal. If you have to go into a mixed number, it's about the same, I suppose. So 13 over 2 or 6.5, depending what the question specifies. And if the question doesn't specify whether they want a mixed number or improper fraction, then I would accept either one. Up to the next one. Oh, look at what we did here. The variable's on the right. That's okay. We can isolate that variable anywhere. We don't care if we isolate the variable on the right or on the left. So I'm just going to leave that negative 4m right where it is. I'm going to look over at this constant term, subtracted 2, and I'm going to make that go away by turning it into an added 2 on the left, like so. So subtracted 2 on the right becomes an added 2 on the left. In the back of your mind, you remember that that's what you actually just did, added 2 to both sides. On the left, 30 plus 2 becomes 32. And is the m by itself yet? No, it's not. There is still a negative 4 with it. Is that a subtracted 4? No, it's not a subtracted 4. That is a multiplied negative 4. Big difference, because we get rid of a multiplied negative 4 by dividing by negative 4 on both sides. On the right side, everything cancels and you just have m. On the left side, you have negative 8. And you can leave it like that if you want. Normally, we'd probably turn it around there and say that our answer is m equals negative 8. And on the last one, the only difference here is that at the end we have some division instead of multiplication, but we still have a constant term there to deal with first. So a subtracted 5 on the left turns into an added 5 on the right. We know in the back of our minds that we just added 5 to both sides. And now, is the s by itself? No, it is being divided by 6. What is the opposite of dividing by 6? Oh yeah, sorry, 2 plus 5 is 7. Opposite of dividing by 6 is multiplying by 6. So I do the same thing to both sides, but I know that whenever I have fraction work to do, so no fraction work on the right, so I just leave that as 6, but whenever I have fraction work to do, I need to turn that into a fraction. So on the left, I multiply by 6 over 1. On the right, I multiply by 6. Look at this. This is multiplication, so we can do our canceling. The 6's just cancel out, leaving 1's behind. In other words, as we expected, all that's left behind on the left side is an s. And on the right side, 7 times 6 is 42. Now, I would say you don't have to show the 6 over 1 there. You could just write that as a 6 and cancel it out. Would also be fine. The big mistake people do make with the fractions, if we look back at this step, is they get confused and they multiply both the top and bottom by 6 when they have a times 6. But remember, when you're multiplying by 6, you're actually multiplying by 6 over 1. Right, so there's those 3. And I got 2 more here, and these ones have just a few last twists on them. The second one, you see we have a fraction. We did look at one like that in our one-step equations, so this will just be a little reminder. This one is a common problem, and you'll notice that in front of the variable there, I don't have a coefficient, so I don't have like negative 3 or negative 8 or negative 12, but I also don't have just a plus sign, so it's not just p, it's negative p, and we're going to have to make sure we're clear on what to do about that. So let's see, I look at this, my variable's on the left, I'm going to have to get rid of that constant term first. And remember, that 9 is not being subtracted. That minus sign is after the 9. That minus sign has nothing to do with the 9. What has to do with the 9 is the fact that there's a plus in front of it that we're too lazy to write, right? It is a plus 9, an added 9. And you'll see I stick that negative sign in red. I did that for a reason that we'll be coming up to soon. So I want to make that plus 9, that added 9 on the left, go away. It's going to become a subtracted 9 on the right. Of course, in our minds, we know... No, I didn't write anything this time. In our minds, we know we just subtracted 9 from both sides. On the right, we have 30 minus 9 is 21. And people will stop there because there's nothing, they think there's nothing to divide by. But let me ask the question we always ask. Is the p by itself on the left side? And the answer is no, it's not. There is still a negative sign in front of it. The p is not by itself. Okay, what does that negative sign sticking in front of the p actually mean? Okay, there we go. What's still with it? A negative sign. What the negative sign in front of the p actually means is it's being multiplied by -1, right? And you'll hear me talk about how we're lazy over and over. It causes students problems more than anything else. Mathematicians are like, hey, if the number in front of a variable is 1, let's just all agree that we're not going to bother to write it down, even though we know it's there. If the sign in front of a number is positive and we don't need to put it there, let's just not write it down. And we'll all just remember we know it's being added, right? All these lazy little things that we do. If a number and a letter are being multiplied, let's not bother to write the times sign. Let's just write them right beside each other. We'll all understand that that's multiplication. Those are the things that cause students all of their biggest problems, and it's sheer laziness. Now, we all like to be efficient, to write less, right? So there's an advantage to it. You don't have to write a 1 instead of in front of the p every single time, right? But you need to know it's there. So we do need to get rid of that multiplied -1. And of course, we do that by dividing by -1. The negative ones cancel. 21 divided by -1 is -21 for our final answer. So negative in front of your variable without another number, you need to remember that is a -1. Over here on the other one, the y is on the left. It's got a thing multiplied, and then a constant term over there. So a subtracted 7 on the left becomes an added 7 on the right. 25 plus 7 is 32. By the way, once you get good, you probably skip this step here as well, right? Just add the 7 over to the right. 25 plus 7, 32. Boom, now you save 2 steps of work. Is the y by itself yet? No, it is being multiplied by 2/3. What is the opposite of being multiplied by 2/3? Well, you could say dividing by 2/3, but we remember that far easier is that dividing by 2/3 is the same as multiplying by 3/2. So I'm going to multiply both sides by 3/2. Why would I do that? Because on the left, I get 3 times 2 is 6 over 2 times 3 is 6. 6 over 6 is 1. It goes away. All you have is the y, right? Meanwhile, over on the right, whenever I have fraction work with a whole number, I have to make the whole number into a fraction, 32 over 1. So on the left side, I have 1 times y, which is y. On the right side, I do have some canceling. Both 32 and 2 can be divided by 2, leaving 16 and 1. So final answer, 48 on the top, 1 on the bottom. In other words, 48. And that is the end of our 2-step equations lesson.